Up to this point, we've been discussing the fluent-data library, and in particular, the dataset class. We've done some of the basic methods, and we ran into one interesting one, which is the group method. We're going to hit another interesting set of methods. We're going to look at the merge-based methods here. These are your join methods, your inner join, left, right, and full joins. And they're also your exists methods. In the future, there may be more than that, but that's the set we have available at the moment. All of these are based on this merge method. It allows you to do much more complex things. If you ever need to do something fairly serious, you can visit it and see if it helps you out. But even these other derived methods are interesting and can help you do things in JavaScript that without the help of a library might be very frustrating. To demonstrate them, let's use the data sets established in the examples here. Actually, let's keep it simple. Let's just work with students and teachers right now. We'll bring in purchases later, time permitting. What we can see here with the students, let me output them as tables. What we have are two people in each data set, represented by rows. You might notice that there's a common person between both. Brielle is both a teacher and a student, whereas Andrea is only a student, and Chloe is only a teacher. If we want to work with joins, we want to combine these somehow. And in particular, we want to do a horizontal combination. So we want to output the name and the topic, but also we want a bias and a school side by side. So for Brielle, we're going to want Brielle, and there's going to be a competition between Bentham or bijection. We'll discuss that in a bit. And then we want Buddhist output and we want Berkeley output. Now, should Andrea and should Chloe come out? Well, it depends on the kind of join you want. We're going to start with an inner join, which means if you're considering a left data set versus a right data set, anything in the left data set, or the first one, only outputs if it also matches in the right data set and vice versa. So in this case, we're going to make students our left data set. We're going to join it with teachers as our right. How are we going to join them? There needs to be some sort of logic that says when one matches with the other. One thing you can do, there's different ways you can do this, but the simplest would be just to use a lambda function. So have one parameter represent a row coming in from your left data set. For us, it'll be students. We'll use S. And then one row coming in from your right data set, T, for teachers. And then use your function to identify when you've made a hit. In our case, when S ID equals T ID, we want to call that a match. Let's output that. Sure enough, and as should be, only one row is outputting because there's Brielle is the only one in common between the two data sets. A doesn't have a match in teachers, and so don't output it. And C doesn't have a match in students, so don't output it. And we have all the properties we were hoping for. We have the ID, which is in both data sets, the name, which is in both data sets. They're the same, so there's no real issue. The topic is in both data sets. There's sort of a competition because they're not the same value in both. The topic for students for Brielle is Bentham. The topic for teachers is bijection, and bijection won out. That sort of goes, if you want to remember which wins out, think if you made an object and you had two of the same key defined in a JavaScript object. So let's say you had an object with a property A, and then you had set it and its value was 1. And then right under that, you had another A with its value of 2. The resulting object is going to be 2 because the second object overwrites the first. Similar to here, your right data set object came second, and so it'll overwrite the first. Let's say we want to do a left join. And you type in join left. The reason left is suffixed instead of prefixed is because in your IntelliSense, if you want to start typing in join, it'll show you all the join methods available. So keeping that the same, now we've got a output, and that's what a left join does. If you're in the left data set, in this case students, output no matter what. Only, and if there's a match, then I'll also output the properties of the other data set. But if there's no match, then just keep those properties null. As we can see, school is null. We don't have school and students, and so when there's not a match, it just outputs as null. And then a right join, of course, reverses that. Join right. And then a full join, the combination. You can output them anything. I think I called it full. There you go. And it's just the properties that are null are appropriately null. Let me make the data a little more complicated. Let's add a second column for Brielle in the teachers. So she'll be listed twice, but her topic might be I'm not very creative today. It's a little late. And then her school will be a B school. I am so uncreative. It is late. I'm just going to call it bool. Notice now there are two B's in teachers. I'm just going over in case you're not familiar with a join. Now we've got two outputs. This is an inner join. We got two outputs because there were two matches. And so both records are output, one for each. That's no surprise to you, but now let's do something a little different. Let's do exists. Now what we're going to do here is output me a record in students if it has any match in teachers. But in contrast to an inner join, we're only caring about the student record, and we don't want to double up. If there's 5 matches in teachers, don't care. It's the same as there's 1. We just want to output one student record if there's a match in teachers. There we go. There's our student's record. The bias is Buddhist. The topic is Bentham, not bijection, because there's no clash, because we're not having anything to do with teachers except checking for existence. Also consider, even in SQL Server, what that syntax looks like. You're writing a subquery, whereas here it's got the same primacy as any of the joins. You also have a not exists, and I think a not exists full, in addition to the other merge methods. I think it might be wise to show some of the options. You might think there's a loop join. It's not. It's unless you can pass in an algorithm as the options. In the options, it's algo, and you can pass in either hash. Right now, only hash or loop. I think there might be a default you can pass in. Either way, it'll try a hash, and then if you can't do it, it'll do loop. But you can force it to one or the other. I would just leave it as the default unless you have a particular reason to do it. But you can also help the hasher along. For example, maybe you want to hash. You can do a left hash, like a left hasher, and a right hasher. And that'll help hash match against these. And then if there's collisions in a bucket, then it'll loop match the buckets using the final thing. If you only want to hash match, I think you can pass null here, and so on. There's different things you can do. If you want to get more into details, just hit the merge method and look at the options available. These are the same options as you'll get in the other merge-based methods. There's more you can do. Only output singular records if you want to do something similar to what might exist in with Postgre capacities. And if you want to play around with more complex things, just look at the merge method in general. But I won't go into too much detail because I could spend forever here. We'll move on to aggregations in the next video.